Good evening. I'm glad you're here. Maybe the day asked a little too much, or maybe you simply like to fall asleep with a quiet mystery nearby. Let the room feel steady, like a porch light that doesn't flicker. Shoulders drift a notch lower. Breathing finds its own easy tempo. Tonight, we'll rest beside a simple, astonishing truth. No matter how hard we try, we can't ride a beam of light. Not because we lack clever engines, but because the universe keeps gentle, unbreakable rules. As you chase light, time itself stretches thin, like taffy pulling slow. Mass grows heavy without end. The energy bill runs off the page. Even the order of moments cause, then effect, stays neatly folded, protected from being tangled. Einstein helped us see this boundary, and in that boundary, there's a kind of safety, a quiet frame that holds reality together. We'll unspool these ideas slowly, one soft thread at a time, until they feel familiar enough to nap beside. If this calm company helps you rest, a small like and subscribe will quietly guide other sleepy travelers to this doorway too. No rush, no pressure. For now, let the night settle. Let your thoughts drift like leaves on a still pond. When you're ready, we'll begin. 300,000 kilometers each second, about a heartbeat of light across the dark. The quiet pace that threads atoms and galaxies alike. Try to catch it, and the world changes under your feet. Not with drama, but with a hush, as if the night itself is reminding us of a boundary drawn in moonlight. Breathe a little slower. Imagine that limit glimmering at the edge of sight, steady as a lighthouse that never blinks. In 1905, a young clerk set down a few pages that unlatched the old stage where space and time had stood apart. The pages suggested they were one woven thing. Space-time and woven things keep their pattern by rules. Among them is a gentle but unyielding speed limit, not a scolding rule, more like the way a shoreline shapes a wave. Water may press forward, but the coast holds its line, and the wave chooses to curl. Lean toward that bright limit, and your body doesn't swell, yet something deep inside grows heavy. The resistance to being pushed, the stubbornness of motion. At 1/10 the speed of light, you'd barely notice the change. At halfway, you carry about 15% more of this stiffness. Nudge to 90%, and it's more than doubled. At 99%, you're roughly 7 times harder to budge. At 99.9, more than 20. Each step closer thickens the air. Not the air you breathe, but the air your motion has to carve. Energy pours in like wind into a sail, and still the boat feels locked to the water. To close the last sliver to light speed, the bill doesn't just go up, it runs off the page. Time changes its gait as well. Your own clock, your pulse, your thoughts moves as softly as always, but to outside eyes it drifts and slows. A lantern swinging more and more lazily on a long night walk. Distances in front of you seem to draw tight, like a hallway narrowing with each step. None of this is trickery. It's the fabric of the world, choosing consistency over convenience, keeping cause ahead of effect, the way dawn keeps ahead of noon. We've watched these rules play out, not only in equations but in rings of steel and magnets that sing beneath Swiss hills. In that underground circle near Geneva, tiny protons sprint at 99.99999% of light's pace. At those velocities, their resistance to being pushed is about 7,000 times what it is at rest. Engineers feed them the steady breath of a small power plant just to grant a whisper more speed, and even then, the finish line keeps sliding away. The protons never touch the beam of light they chase, because to do so would require an energy that doesn't exist to be given. The universe refuses politely, and the refusal is measurable, reproducible, beautifully mundane. This limit isn't a fence built to frustrate wanderers. It's a seam that keeps the quilt from tearing. If anything moved faster than light, messages could arrive before they were sent, causes could trail their effects, and the orderly conversation of events, the reason your memories sit behind you and your possibilities ahead, would knot itself into paradox. The speed of light is the cadence that prevents that tangle. It is the quiet metronome of reality, clicking along whether we're listening or not. Let that be a comfort rather than a cage. The cosmos is wide enough for awe without sprinting past its own rules. Rest in the thought that boundaries can be kind. They hold shape so we can dream within it. If these gentle wanderings help your night feel softer, a light touch on like and subscribe quietly helps other sleepy travelers find this shore as well. No urgency, just a small lantern left on for a friend. Now let the breath rise and fall, moonlight on a still pond, and let the mind drift where the numbers glow, like distant towns, faithful, unhurried, true. Like that moonlit pond, time doesn't stop all at once. It softens its stride, a clock deciding to whisper. Move faster, and the whisper slows further. Your pulse still feels ordinary inside your own skin, but compared with a friend resting at home, your moments lengthen, your minutes stretch. This unassuming tilt of time dilation, doesn't ask for belief. It simply happens, the way moonlight happens on water, whether or not anyone is watching. Up above the night side of Earth, small machines drift in cold arcs, carrying careful clocks. Their ticking refuses to match ours exactly. Motion tries to slow those ticks. Height above Earth's mass tries to speed them up. Both influences matter. Engineers fold special relativity and gravity into the math each day so that maps on our phones don't slide the way a loose rug slides. Without those quiet corrections, positions would drift by miles, and morning walks would end somewhere unexpected. The cosmos does not shout its rules. It tucks them into the gentle arithmetic of everyday tools and lets us discover them by missing our turn. Lean deeper into speed, and the strangeness brightens, not harshly, but like dawn easing across snow. Take a small craft and aim toward Proxima Centauri, a lantern 4.2 light years away. From the shore of Earth, the trip is a little more than 4 years at near light pace. Inside the cabin, if your speed brushes 99.9% of light, a calendar on the wall would hardly have time to curl its corners. About 2 months of your lived time before you reach that distant lantern. Press closer still to 99.999%, and your experience narrows to days. Outside, time stretches like taffy. Inside, it feels simple and domestic, the ordinary rhythm of tea cooling on a table. 2 siblings make the story vivid. One rides the ship out and home again. One tends the house and waters the plants. 50 years may pass on the porch, while only a small handful pass in the cabin. The paradox dissolves once you notice the traveler has to turn around, has to feel the nudge of acceleration that the one at home never feels. Space-time keeps perfect accounting. No one is cheated, and no one is spared. Each path through the world has its own measure of moments, and the measures agree when the reunion hugs are done. Of course, Speed is not granted by wish. It costs. Every notch closer to light requires energy poured in like grain into a mill, and the mill always asks for more. Push a single kilogram to 90% of light, and the energy tally climbs toward the yearly work of a small nation's power lines. Then, add a zero to creep from 90 to 99. Add another to creep from 99 to 99.9. The demand steepens into a cliff. There's no summit to plant a flag on. The path simply stands straight up against the sky. Our swiftest emissary, the Parker Solar Probe, skims the sun in a bright, perilous ballet, about 195 kilometers each second, fast enough to loop Earth's waist in minutes. Yet compared with light's 300,000, it is a slow leaf on a wide river, roughly 0.06% of the river's rush. Voyager 1, patient and faithful, sails at about 17 kilometers each second. At that pace, a single light year is a task for more than 17,000 winters. The gap between our reach and light's stride is not a narrow canyon to jump. It is an ocean whose other shore is a kind of never. As speed grows, the hallway in front of you seems to narrow. Distances along your path contract, not as an illusion, but as the geometry the universe prefers under stress. That same 4.2 light-year stretch from inside a ship at 99.9% of light shortens to roughly 60-something light days. The map itself redraws. What looked like a continent folds into a walkable lane. Nothing cheats. The folding and the slowing are two faces of one woven rule. Carry the thought to its edge, and a delicate idea appears. For anything that rides on zero rest mass light itself, there is no cozy seat in which it can be at rest. In our equations, the proper time along a photon's path is zero. No waiting, no between. Emission and arrival are different places for us, but the math says they touch for light. That is why nothing with mass can truly catch the beam. To catch it would be to let your own time collapse to nothing, to leave the realm where clocks and living make sense. Energy and mass are not rivals. They are partners, changing costumes. E equals mc squared is written like a headline, but it reads more like a marriage. Put energy into a thing to push it faster, and that energy itself weighs on the motion. The heaviness is not a feeling in the hands. It's the deep stiffness of inertia, the reluctance of an object to change its state. It's like filling a pail that becomes thicker iron with each ladle, each drop making the next drop harder to add. The bucket and the water are becoming one story, and the story resists. People once suspected light might be instantaneous, a divine arrow without travel time. Then, a moon of Jupiter blinked late, and a Danish mind noticed. Centuries later, a wheel with teeth chopped starlight into timing marks and mirrors on long baselines clinched the number again and again. No banners, no fanfare in the night sky, just careful timing, patient subtraction, and the conclusion that the universe keeps a steady beat. Knowing that beat is why our ships navigate, our signals agree, and our theories don't shake themselves apart. Aim your bow toward the stars at relentless speed, and the sky itself reshapes. The headlight effect gathers the constellations forward, crowding them into a bright oval. Behind you, the lights thin into a velvet emptiness. Colors tip as frequency shifts. Ahead, familiar starlight slides toward blue, then ultraviolet, then into radiation with names that feel surgical, X-rays, gamma rays, until what rushes at your hull is not a view, but a hazard. Behind, red shifts to redder, and slips beyond sight, a dusk that does not end. Even the cosmic microwave background, the cool afterglow of the Big Bang, blue shifts into a hard glare at high enough speeds. You are not so much looking out a window as leaning into a wind of light. Fields respond too. Electric and magnetic threads that usually lie quiet around charged particles tighten as speed climbs. Strength multiplied by the same factor that slows your time. Bend a near-light particle, and magnets must roar. Twirl charges in a circle and they shed energy in glittering sprays, synchrotron radiation like sparks from a grinder. Translate that to matter arranged into cells and circuits and you meet an orchestra that cannot stay in tune. Bonds that keep molecules married, stretch, and ring. Electrons meant to loiter in neat shells, skid, and leap. The tidy agreements that keep devices honest start to fail. Near light's tempo, organized matter becomes a choir asked to sing in a hurricane. And space itself, so famously empty, proves to be populated enough to matter. Between stars lies a thin broth of hydrogen atoms, dust, and shards of cosmic rays. Drift through it slowly, and it is benign as fog. Plunge through at relativistic speed, and each hydrogen atom carries the punch of a laboratory beam. A single dust grain is a small, unrequested meteor. The faster the dive, the harder the rain. Shielding can help, but every slab you add for safety adds mass, and every kilogram of mass demands more energy, and more speed multiplies the very danger you hoped to block. The loop tightens until the plan eats itself. Numbers turn unfriendly here. At 99.9% of light, those lonely hydrogen atoms become a radiation bath, fierce enough to make an unshielded reactor seem conversational by comparison. The way out would be armor so thick it becomes a destination of its own, a mountain you hope to push to near light, calling for energy in a rising chant that never crests. The arithmetic does not argue. It simply refuses to cooperate. The mind, resourceful and stubborn, looks for paths sideways. It sketches tunnels through space-time wormholes and surfing tricks warp bubbles that move space rather than racing inside it. The equations do not forbid such shapes, but they ask for ingredients the pantry does not stock. Negative energy densities, pressure that pulls instead of pushes. Hints exist in narrow places, the Casimir effect whispering between metal plates a hair's breadth apart, but the amounts are thimble small and the control is slippery. To build a road for a ship, you'd need oceans of the stuff, whole planets worth of mass converted to architecture. The blueprint is mathematically tidy and physically outrageous. Entanglement tempts with its own shimmer. Two particles born as twins share a pattern so deep that a measurement on one predicts the other's response. As if a coin tossed here and a coin tossed far away always complement each other's faces. The update looks instant, and a mischievous mind hopes to tuck a message inside it. The hope dissolves on contact with the details. Results arrive as perfect nonsense until the notes are compared the slow way. The universe permits correlations that reach across gulfs. It does not permit those correlations to carry meaning faster than light. The door looks ajar and is, in truth, a mural of a door. Under all the cleverness lies a simple kindness. Cause and effect keep their order. That is what the limit protects. Break it, and before and after can tangle until a message arrives before it is sent. A deed outruns its reason. A life steps on the moment that made it possible. The world's logic would fray like an old net. Instead, the light speed boundary holds the weave tight. Clocks disagree in lawful, consistent ways. Rulers shorten along the line of travel in lawful, consistent ways. Energy bills match the work done, painfully But honestly, the rules hum the same tune in every reference frame, and reality remains a story you can read forward. The comfort in this is not small. Limits can feel like cold fences until you notice what they keep safe. A shore makes waves beautiful. A frame makes a painting more itself. A heartbeat is precious because there is never an infinite number of them. The speed of light does not stand against us. It stands with the grammar of the universe, keeping sentences legible. Inside that grammar, we build probes and clocks and songs. We drift along corridors of time that stretch or shrink according to our path. And still the tea cools and the cat wakes and the porch light hums. Imagine the cabin again, a small window, a plant in the corner braving the sway, a watch with a second hand that does not know it is special. Outside, stars gather forward into a white, quiet cyclone. Behind, darkness opens like a curtain that will not close. The ship hums, the body breathes, the math does not blink. The numbers are stern and also gentle, because sternness that is universal becomes a kind of mercy. You are held by the same rule that holds galaxies. There is wonder enough here, even without the promise of a shortcut. Wonder in the way a satellite's pulse must be corrected for both motion and altitude. Wonder in the way a proton, whipped to fantastic speeds, carries the weight of thousands of resting protons. Wonder in the way a dust mote can become a meteor at the right velocity, and a microwave whisper can turn into a hard glare. Wonder, too, in the refusal, in the way every plan that tries to slip past the limit is turned back, not by a scolding, but by arithmetic so consistent it becomes a lullaby. Let the thoughts settle like snow. Light's pace is not ours, and that is all right. We move within a slower music, and the slower music is full of rooms and meanings. Time will bend for you if you ask correctly by choosing a swift path and paying the price in energy and patience, and it will bend for your neighbor differently, and both bends will agree. That agreement is the peace we live in. The rest is sky. If the mind keeps walking, it can visit edges, blue-shifted horizons, magnetic walls, wormholes sketched in pencil, entanglements, spooky coin flips. It can visit and then return to the couch, to the soft beat in the ribs, to the window where a streetlight trembles on frost. The speed limit remains, steady as a lighthouse. Ships do not reach it, stories brush it, and learn how the world holds together. Breathe the rule in and out like a tide. Let the stars crowd the forward glass, and then drift back to where they belong. Somewhere in that slow exhale, the universe feels both immense and intimately ordered, like a quilt pulled up to the chin, stitched, warm, and patiently bright. Back on Earth, beneath that lighthouse steady rule, far below mountains of concrete and superconducting wind, nuclei race in bright circles. When the ions are heavy gold, lead their shapes to a quiet contortion as speed piles on. The sphere you'd sketch in a textbook flattens like dough rolled under a careful hand. At 99.9% of light's pace, that gold nucleus thins to a disk less than a femtometer thick, a wafer so slight it's almost only a surface. We don't have to guess the pattern left in their collisions, how shards spray, how angles cluster spells out the geometry they wore while they were moving. In those ring-bright moments, the universe shows that space itself chooses who gets to keep their roundness. Step back to a scale so large, it feels like weather. Galaxies drift apart, carried by the slow swelling of space. far enough away. The separation grows faster than light could cover. No law broken, because nothing sprints through space that quickly. Instead, space lengthens between the shores. That's why there are domains we will never visit, not even with time as our ally. Beyond a certain horizon, light launched toward us will be plucked backward by expansion, like a note pulled thin until it vanishes. The observable world is a lantern in fog, not because the fog is near, but because the night is growing. Where the large and the tiny meet, uncertainty writes its name. Quantum mechanics tells us that position and momentum refuse to be pinned at once with perfect grace. As speed climbs, and energy climbs with it, momentum swells not just in size, but in the range you must tolerate if you try to confine the particle to a small place. Try to squeeze both location and motion into neat boxes, and the boxes split their seams. Push harder, cram more energy into a tighter region, and the vacuum answers by stirring. Pairs spark and cancel. New quanta flash in and out. What began as one traveler becomes a crowd of possibilities. The simple picture of a single object, with mass, moving like an arrow, grows ragged at the edges until where becomes a poem you cannot quite recite. It is tempting to put a human heart in this story and ask how it would fare. Bodies learned their craft under gentle acceleration, 1G, a steady drumbeat of Earth. Cells arrange themselves like careful neighborhoods. Proteins fold into keys. Blood takes its cues from pressure and timing. Under relativistic demands, these agreements would be tested in ways biology never rehearsed. Radiation sharpens, fields intensify, clocks stretch in one frame and not another. Chemical reactions depend on timing and energy windows that a furious rush might shift. The iron that carries oxygen, the calcium lattice that keeps a step sure, the long molecules that remember who you are, all would be asked to function in a storm of factors pulling them off key. We have never flown a living body into those conditions. The best models we build whisper the same outcome. Systems desynchronize, defenses saturate, damage outruns, repair. Then there is the quiet arithmetic of time and how it leans on the soul. Picture the cabin of a traveler where weeks pile up like folded towels, while on the ground years stride past. Letters from home grow old between sentences. The return, triumphant in one sense, lands in a garden in another season of history. Friends who waved at the launch walk with slower steps. Songs that once meant summer now belong to someone else's radio. None of this is science fiction. It's simply what clocks do when paths through space-time bend differently. The physics is clean. The feelings are not obliged to be. Energy, forever the bookkeeper, keeps its own cliffside ledger. Add energy to go faster, and the energy itself contributes to inertia, tightening the knot you're trying to climb. Keep concentrating that energy into the small, sturdy architecture of a craft, and a theoretical shadow appears at the edge of the chalkboard. If a region holds enough energy in a compact ball, gravity can curl it shut into a horizon. No one is proposing a starship that implodes into a black bead on the launch pad. The point is gentler and still unforgiving. Any route that gathers stupendous energy densities in small volumes skates near thresholds that nature enforces with calm indifference. Even the vacuum, which sounds like nothing at all, has a texture that shows itself to someone who accelerates hard. Quantum fields flicker with virtual pairs that usually cancel like a tide, leaving no footprint. For an observer pushed with colossal, sustained acceleration, that hum takes on warmth, the Unruh effect. like feeling heat from a fire that isn't in any one location. Turn the drive high enough, keep it high long enough, and the bath grows hotter, not from engines leaking, but because your motion changes what empty means. The road you build under your own thrust comes with a glow. Radiation itself narrows into a kind of spear at high speed. That's relativistic beaming. Any light you shine, any radio you transmit, compresses forward into a tight cone. Behind, the same emissions fade to a thin drizzle. Colors tilt with it. Signals launched toward home are stretched and softened. Signals ahead of you harden and crowd into smaller wavelengths. Headlights become not beams for seeing but blades that could cut the very dust, while anyone following in your wake would struggle to notice you at all. Communication becomes an exercise in careful geometry and patience, with every message forced to reckon with a sky that bunches in front and empties behind. For a different kind of speed lesson, consider the craft that already carry our badges. One probe, dipping close to the sun, stitched gravity assists into a sling and briefly reached well over 100 kilometers each second. Engineers shaped its path through repeated kisses with Venus, threading a dynamical loom. Against light's tempo, though, it remains a careful jog. Decades of craft, talent, and money move the needle to 1/10% and a little more. A triumph that still underlines how far the summit is from the trailhead. Nature, meanwhile, throws stones harder than any machine we've built. Cosmic rays, protons, and nuclei flung from supernova shocks, from black hole environments arrive with energies that make accelerator halls feel modest. One famous visitor carried the punch of a pitched baseball in a single proton's motion, a number that sounds like a prank until the instruments confirm it. Yet even those daredevils fall short of the limit, skating at 99.99 and more, never quite erasing the tiny sliver that separates almost from is. Back on Earth, a constellation of clocks rides in high orbits and refuses to keep time like their cousins on the ground. The difference is delicate, tens of microseconds each day, but relentless. Speed tries to slow the ticking. The gentler gravity up high tries to speed it. The two effects combine into a steady offset that engineers must keep trimming. Leave it alone, and the map in your pocket would drift by kilometers, not because the hardware is sloppy, but because space-time is tidy. The daily maintenance of accuracy is a standing tribute to a universe that insists on being precise, even when it's being strange. Hold, for a last quiet moment, the perspective of light itself. Strictly speaking, there is no armchair where a photon sits and checks its watch. A photon has no rest to rest in. But the geometry says something severer and more beautiful. Along a light-like path, proper time is zero. Between emission and absorption, there is no during for the light. In the limit where speed leans all the way to light's own stride, length along the direction of travel contracts toward nothing. Distance loses its meaning the way a melody loses its duration if you could hear it all at once. That's why mass cannot be carried to that pace by any honest push. To get there would be to step outside the very grammar that gives before and after their quiet order. The laboratory lessons and the skywide lessons rhyme. Flattened nuclei tell you that motion edits shape. Expanding space tells you that separation can outrun any chase without anything locally breaking the law. Quantum uncertainty tells you the world refuses to be both certain and sharp on all sides at once, and that Pushing too hard on one certainty summons a crowd of new actors. Biology tells you that systems tuned for one tempo find disorder when the band changes suddenly. Psychology tells you that time's fairness on paper can be hard to bear in a kitchen. Energy tells you that invoices escalate to the absurd. And geometry whispers that some thresholds are guarded by the structure of reality rather than by difficulty alone. If you picture a ship all the same, see it not as a defiance, but as a conversation partner with the rules. Its hull is lined with fields to cushion particles that hit like needles. Its instruments expect the sky to crowd forward. Its radio sings in careful frequencies that account for shifts and cones. Inside, the traveler knows that months can be a lifetime, and years can be an afternoon depending on the path, and breathes with that knowledge, the way one breathes with a metronome ticking somewhere in another room. There's tenderness in limits when they reveal how much can still be done. We can bend clocks into agreement across the planet and steer by them. We can learn from ions flattened to paper that motion doesn't merely carry you, it sculpts you. We can listen to the hiss of cosmic rays and hear the tale of distant engines. We can do arithmetic with expansion and accept that some shores recede faster than any boat and still launch boats for the beauty of the water we can cross. Not every boundary is a wall. Many are coastlines, rich with inlets and currents, telling you where the deep water begins. So let the mind idle, like a nighttime train gliding past towns with sleeping windows. CERN's rings, the wide breadth of the universe, the small rebellions of quantum rules, the stubborn kindness of causality, they all hum the same soft tune. Speed can be chased, but not seized. Information can flirt across entanglement, but not gossip. Faster than light. Space can swell, but no traveler can outrun their own light cone. In that steadiness, there is an invitation, not to despair, but to rest. The cosmos is vast and intricate, with tempos nested like shells. We move within one of them, slow enough for conversations, photographs, gardens, promises. Light runs the long errands. We warm the room. From that shared tempo, notice the color it sometimes wears here on Earth. Blue, the signature that appears when matter outruns light in a medium. In clear water or glass, light's pace is slower than in the open vacuum. A charged particle can slip through faster than that local limit and leave a rippling cone of photons behind Cherenkov radiation, the optical cousin of a sonic boom. Reactor pools glow with that cool electric aura. It looks like speed itself breaking loose, but the deeper rule stays intact. Nothing ever beats light's vacuum stride. Far beyond any pool or lab, space-time carries its own music. When two neutron stars collided in a distant galaxy, their crash sent tremors through the fabric of reality and a flash across the dark. After roughly 130 million years of travel, the gravitational waves and the light reached us within seconds of each other. Different messengers, same tempo. The universe seems to keep one master cadence for information and causality. Now and then, rumor suggests a loophole. Tachyons, imagined particles that always live beyond light speed. On paper, they would have imaginary mass, would demand infinite energy to slow down to light speed, and would tug cause behind effect. Diaries would fill with contradictions. We have searched for footprints. The trail remains empty. It is as if the cosmos has carefully hidden every door that would let chronology trip over itself. Some theories sketch the limit as geometry rather than decree. In string-inspired pictures with curled extra dimensions, Information can only hop from one vibration to the next so fast. The speed of light is not a knob someone set, it's the grain of the wood. Whether those extra dimensions survive future tests or not, the suggestion is elegant. The limit is woven into the instrument. The arithmetic of propulsion tells the same story in a plainer voice. Take a modest craft, 1 metric ton, and ask it to cruise at 90% of light speed. The bill runs to the energy output of civilization for years, and that's under a fantasy of perfect efficiency. Real engines leak heat, real systems waste, and every spilled joule becomes a burden you must lift again. Storing that energy, shaping it, and bleeding away the heat without cooking the vehicle, multiply the cost. Radiators would need to unfold like black wings. Wings add mass. Mass demands more thrust. More thrust means more energy. The loop tightens. Behind the engineering sits a quiet tyrant, the rocket equation. Every drop of propellant you carry must be pushed along with you. Fuel to push fuel, tanks to hold tanks, structure to hold tanks that hold fuel to push fuel. The curve turns exponential with startling speed. Chemical propellants are glorious for leaving the ground and visiting nearby worlds, but hopeless for courting light's neighborhood. Nuclear options promise more momentum per kilogram, yet still fall short by gulfs, not gaps. Antimatter gleams in equations, offering nearly perfect conversion from mass to motion, but we make it atom by atom at ruinous expense and store it only in small, fussy traps. Tons live in fiction. In laboratories, the units are counted with murmurs. Lift your eyes to the largest scales and a different kind of boundary emerges. Space itself is stretching, slowly but steadily. Over grand distances, the stretch accumulates until galaxies recede faster than any beam could chase them. Nothing is sprinting through space at superluminal speed. More space is simply appearing between shores. The result is a horizon that no traveler can cross and no telescope can pierce. Even a perfect light-speed ship would find most of the cosmos forever out of reach. Our accessible bubble changes with time, yet always leaves much of the whole unvisited. Matter does not shrug off these demands. Electrons are not tiny planets. They are standing waves of possibility, shapes set by energy and symmetry, drive atoms into extreme motion, and their internal timing shifts. Nuclei and electron clouds respond differently. Allowed energy levels slide. Bonds that should clasp may crack. Molecules may ionize where they should hold fast. The delicate exactness that makes chemistry dependable, oxygen hitching a ride on iron, a receptor clasping a messenger, depends on patterns that relativistic strain can distort. Life's toolkit was tuned for one tempo and one neighborhood. Near light's cadence, the tools might refuse to fit. Even the way things look asks you to be careful. An object racing past does not simply shrink along its motion. It appears rotated. That is the Penrose-Terrell effect. Light from the far side takes longer to reach you than light from the near side, and your eyes assemble an image from photons that left at different times. A sphere stays a sphere but seems turned. A cube shows faces that should be hidden. Perspective and finite signal speed weave the picture together. Steering by stars under such conditions becomes a puzzle. At 99% of light speed, the heavens squeeze into a bright disk ahead, while the rear view fades toward black. The forward glow is not gentle. Wavelengths pile up, shifting toward ultraviolet, X-rays, and gamma rays. Scenery turns into hazard. Instruments must be shielded, and shielding adds mass, which asks for more thrust, which asks for more energy. which demands more radiators. Another spiral, quiet and relentless. Navigation becomes pre-computed choreography instead of simple sighting. Thermodynamics doesn't look away either. Entropy, the measure of spread and irreversibility, likes to climb. Motion changes how temperatures transform from one viewpoint to another, but careful bookkeeping never yields a free lunch. A device that seems to skirt the second law in one frame fails when you account for signals and work in all frames together. The arrow of time doesn't reverse because you picked a clever angle on the problem. The laws insist on a consistent story. Signals you emit at high speed tell their own tale. Radiation concentrates into a tight forward cone, relativistic beaming so headlights become cutting lances and taillights turn to whispers. Communications must plan for blue shifts and red shifts, for cones and null zones, for receivers that see something very different than what transmitters think they sent. The very act of announcing yourself becomes directional. The evidence that all these constraints are real isn't hiding in obscure corners. We see a reactor pool's ghostly blue and learn that local outrunning is permitted, while global outrunning is not. We watch gravitational waves and light arrive together from far-off cataclysms and infer a universal pace for messages. We hunt for tachyons and find silence where paradox would have been. We write down propulsion budgets and watch the rocket equation turn ambition into exponentials. We look across the sky and notice a horizon written not in stone, but in expansion. We model atoms and see how speed asks chemistry to change its mind. We calculate what your eyes would see and find that geometry edits appearances. We check the thermal books and discover that the ledger is balanced in every frame. Hold a smaller image for comfort, a vessel gliding through something so transparent it looks like nothing. The stars gather forward into a shining coin. Behind, a soft, dark opens. Inside, the air smells of metal and paper. An instrument ticks in a steady way. The ship's own lamps focus into narrow spears. Radiators unfurl like black leaves. Particles in the thin interstellar medium arrive like needles. Fields rise to meet them. Guidance does not improvise. It keeps time with an equation. The room is quiet, respectful of rules that don't bend and don't scold. You can feel the limit without touching it. In that hush, the speed of light stops reading like a wall and starts reading like grammar. It keeps causes ahead of effects. It keeps navigation meaningful. It keeps chemistry faithful. It keeps engines honest. It even keeps beauty intact. The blue ring in water, the synchronized arrival after 100 million years, the clean symmetry of a law that does not change at the edge of town. Boundaries like this don't shrink wonder, they frame it, the way a shoreline frames a sea. We live and think within that frame, building clocks that agree across continents, skating probes close to the sun, piecing together mergers we cannot see with eyes alone. A limit can be a lullaby when it is everywhere and always, the soft metronome by which the universe breathes. Within that same frame, the grammar turns practical. Step into the great halls of circular machines, where magnets hum and vacuum sings, and watch the rule grow teeth. Bend a charged particle, even slightly, and it answers with light. The faster it runs, and the tighter the turn, the stronger the answer becomes. First a shimmer, then a glare, then a storm of X-rays that steals energy as quickly as you can feed it. This is synchrotron radiation, the toll booth on every curved path. At modest speeds, you can pay and pass. Near light's tempo, the toll eats the trip itself. It's not a leak you can patch. It's a law that says acceleration along the curve is a kind of lantern, and lanterns must burn fuel. There is also a background presence we still speak about in a careful voice, like something you don't want to scare away, the Higgs field. It threads every inch of space, a quiet, uniform hum. Particles gather their mass by coupling to that hum, the way a bow gathers sound from a string. Whether this coupling changes its texture at extreme gamma, whether the field itself enforces a gentler sealing than the equations yet show, that remains a question with soft edges. You can imagine a deeper mechanism, a hand beneath the table, keeping anything with mass from ever quite learning the light's last step. Engineers have tried, in sketchbooks and studies, to climb as far as craft can climb. One vision scattered pellets of fire, Project Orion's nuclear pulses, pushing a plate like a drumskin until the ship rode the beat. Even with magazines of star-bright charges, the promised cruise lingered at a few % of light. Another design, Daedalus, wore fusion as its heart and planned decades of steady shove to reach on the order of a tenth, perhaps a little more, of light's pace. Those drawings were not timid. They were cathedral-sized attempts, and still, the speeds were small beside the threshold we are tempted to name. Ahead, the path is not empty. Interstellar space hosts a mist of atoms and flecks, thin as the faintest breath, and yet, at speed, deadly. At a tenth of light, a single grain of dust strikes like a bomb. At half, such a grain carries the violence of a battlefield's sun. By 9/10, lone hydrogen atoms become needle bullets you cannot dodge or reason with. Armor can be layered, and fields can be shaped, but each remedy adds weight, and weight calls for thrust, and thrust calls for energy, and energy adds its own gravities. What looked like a highway becomes a shooting gallery where even the road is throwing stones. The small world adds its puzzles. Quantum tunneling lets particles slip through barriers that classical minds would call walls. At gentle speeds, it is a rare and useful strangeness, powering reactions in stars and biochemistry in cells. Under relativistic conditions, the probabilities can twist. Barriers grow thinner or thicker, depending on how energies and frames tangle. The tidy catalog of reaction rates blurs. Nuclei negotiate new bargains. Bonds that seem dependable develop bad habits. Matter behaves like a crowd in a storm. Familiar faces, unfamiliar choices. Even if velocity were granted, the conversation with home would fray. Doppler shifts wrench frequencies until signals in front harden into harsher light, and signals behind dissolve toward longer waves. Beaming squeezes transmissions into a narrow cone. Misalign a little, and you miss everything. Time plays its own trick. A back and forth that feels like minutes in the cabin stretches into years on the porch. Dialogues become histories. Replies arrive as artifacts from a younger self. Isolation is not only distance, it is tempo. Two particles charging toward one another offer a subtler reassurance. Intuition tries to add their speeds and break the limit. Relativity replaces addition with a woven formula that keeps the sum under the ceiling. Always. Head on at 99% each is still shy of light as seen from either side. The rule is not a fence you can jump by cleverness. It is the curvature of the landscape itself. Underneath these specifics sits a map of reality that trades poetry for precision and still sounds like a kind of music. Space and time are not separate stages. They are one fabric, with axes you can lean between. Everything with a world line moves through that fabric at a single, grand pace. Call it c, the magnitude of the 4 velocity. Sit still in space, and you spend your entire allowance on time. Start moving across the floor of space, and you must spend less a long time to keep the total constant. To move at light speed through space would be to spend your time allowance down to zero. Clocks inside you would have nothing left to tick. For anything made of mass and memory, that absence is not a place you can live. The vacuum that hosts all this is not vacant. Quantum fields tremble even at rest. Pairs of almost particles appear and cancel in a murmur that usually nets to silence. Change your state, accelerate hard, and keep accelerating, and that murmur takes on heat. The Unruh effect says the more fiercely you press the throttle, the warmer empty space looks as if you had flown a stove into being around you. Approach the accelerations that would be needed to chase light's edge, and the stove becomes a furnace. The fire is not from engines, it is from definition. What nothing means depends on how you move. Energy is not merely bookkeeping, it is also gravity's handwriting. In general relativity, anything that carries energy or momentum curves the stage a little. Kinetic energy at extravagant levels becomes its own source of curvature. Squeeze enough motion into a small volume and you begin to lens the world, to tug on trajectories you did not mean to touch. The nightmare image is a starship that pulls space-time into risky shapes by the very act of trying to be quick. Even well short of catastrophes, the idea should add quiet to the control room. Inside laboratories, the same pattern repeats with different costumes. Charge a ring with particles and turn the magnets until the path is nearly pure circle. The beams answer with light first visible, then ultraviolet, then X-rays that paint ghostly images of bones and crystals and protein folds. The brighter you make the beam, the more it sings, and the more it sings, the faster it robs itself. Experiments build straighter machines to soften the bend, heavier superconductors to steady the turn, cavities that spoon more energy into each lap, always dancing on the edge of a law that will not let you steal more than you can pay back. Beyond the lab, the old proposals sit like models in a museum case. Pusher plates and pulse units, pellets and reactors, trajectories that would take years to wind up. Their power is not that they promise what they cannot. It is that they show how brave a design must be, merely to flirt with 1/10. In that honesty, there is a kind of comfort. It tells you where craft ends and the architecture of the universe begins. Consider the human scale again, this time as ritual instead of warning. A traveler rehearses the course, not expecting star-leaping speed, but honoring the rules like a liturgy. Shielding is arranged as layers and fields, like coats for different weathers. Communications are scheduled like tide tables, with allowances for shift and cone and silence. Instruments anticipate false colors and strange angles, a sky that shows more of a cube than it should and keeps a sphere round while making it look turned. The ship is less an arrow and more a shrine to consistency, moving through a medium that answers in predictable, sometimes severe ways. Philosophy nods here, not as ornament, but as structure. A speed limit preserves order in stories. Cause precedes effect. Signals carry meaning only at or below the universal stride. Knowledge propagates with horizons that give shape to what can be known when. Remove the limit, and you do not simply gain convenience, you lose coherence. Diaries would contradict themselves, and the future would bleed into the present in ways that empty responsibility of sense. The limit is not an enemy. It is the grammar that lets sentences hold. Even the numbers that feel like riddles are invitations to rest. Saying everything moves at sea through space-time is a way to respect the bookkeeping that keeps different observers honest with one another. A photon spends its entire allowance across space. A stone spends almost all of it a long time. A human spends most on time, with a little on walks and dances. Trade some here, you must trade back there. The exchange rates are fixed and fair. Gather the pieces, and a picture forms that is intricate but not cruel. Curved paths radiate. Fields grant mass and likely keep it tethered. Dust becomes shrapnel. Tunneling refuses guarantees. Messages thin into cones and split into mismatched intervals. Additions of speed fold under a formula that prevents cheating. Rests and runs add to the same invariant length through the world. Vacuum warms to the accelerated. Energy weighs on geometry. Each statement threads quietly into the next, not as a wall repeated, but as different stones in the same arch. Hold that arch in mind the way you hold a melody. It does not rush. It does not permit a scream to arrive before the throat opens. It does, however, allow for craft, for patience, for designs that touch the possible and report back with photographs and spectra and waveforms. It makes room for reactors that glow blue in deep water, for detectors that feel the tremor of merging stars, for engines that pulse and plates that ring, for magnets that guide and cavities that sing. The limit is not the end of motion. It is the measure by which motion keeps meaning. Somewhere, late in the shift at a collider, a control room lamp burns low, and a graph creeps across a screen, honest as a heartbeat. Somewhere else, a study lamp glows over a 1,970 seconds blueprint, labeled with a mythic name. Somewhere much farther away, a cosmic ray fizzles in a detector and writes a short, fierce line that still falls shy of forbidden speed. And here, in a room that is not racing at all, breath settles into its tide. The distance between what can be imagined and what can be built is not an insult. It is a landscape, and landscapes are for looking, for walking, for learning the names of the birds. The speed of light runs like the river that gives the valley shape. We live on its banks, and the banks are where villages thrive. And along those banks, in 2012, a small rise on a crowded graph told a quiet story about why anything weighs anything at all. The Higgs boson announced a field that never turns off, a background note every massive particle can hear. Photons don't, which is why light slides along unburdened. Electrons and quarks do, which is why they feel inertia like a hand on the shoulder. The limit we keep brushing isn't an arbitrary sign on the roadside. It's carved into the instrument. Ghost-like travelers add their lesson. Neutrinos so slight they cross planets without a backward glance, still fall short of C. When a star in the Large Magellanic Cloud tore itself open in 1987, neutrinos slipped free at once while light fought through layers of blinding plasma. Hours later, the supernova bloomed to our eyes, yet even those early neutrinos obeyed the same ceiling. A whisper of mass is still a tether. Think in the scale of a cabin, at a tenth of light speed already far beyond our engines. Proxima Centauri waits more than 40 years away. 4 decades for metal to fatigue, seals to dry, crops to cycle, mines to stay steady. A galaxy that spans 100,000 light years shrinks no faster under ambition. Distance in a kind universe remains distance. In laboratories that choreograph light, Materials with negative refractive index bend beams backward, and dense, chilled media slow pulses to a stroll. The tricks are elegant, yet the message never outruns its vacuum stride. In those media, photons hand the baton to atoms and take it back again, a relay that looks like delay. Different costumes, same tempo, as if reality built redundancies to keep causality neat. Lift your gaze to the sky, and the gentle becomes fierce. The cosmic microwave background, a cool afterglow filling all directions, turns harsh when you rush toward it. At extreme gamma, that soft radio hush, blue shifts into radiation with teeth, threatening hull and tissue alike. The universe's oldest photograph becomes a storm when you insist on sprinting through it. Matter's strangest costumes stay obedient. Time crystals repeat in time rather than space and sound like a dare to thermodynamics. But careful experiments show discipline, not defiance. No free engines, no loophole through C. Even when we coax matter into non-intuitive rhythms, the ceiling holds. Quantum rules lace the story with restraint. Watch a system relentlessly, and you can stall its change. The quantum Zeno effect, because each measurement collapses a bloom of possibilities back to a narrower present. A particle pushed at colossal acceleration faces something similar in the sea of fluctuations. The Unruh effect says empty space warms under sustained thrust, as if the vacuum turns into a low-embered furnace. The harder the push, the hotter the bath, the thicker the air of nothing. Nature runs experiments we cannot schedule. From the centers of active galaxies, jets lance outward, driven by the ferocious bookkeeping around supermassive black holes. Their particles brush 99.99% of C. Across billions of light years we read their spectra and timing. They approach, they never cross. Even with a black hole signing the checks, the ledger closes under the same constant. Information follows the same discipline. Let a signal outrun light, and you invite cause to trail effect. Diaries would not. Choices would echo into their own beginnings. The limit is a promise that stories can be told in an order every reader can reconcile, no matter their motion. Meaning depends on that promise. There are rooms where light appears to pause. In Bosa, Einstein condensates. Photons enter, lend their identity to collective excitations, and later emerge so the front of a pulse seems to stop. Nothing illicit occurs. It's storage, not cheating. The fastest lane for information remains vacuum, and its speed remains bounded. From a higher balcony, a principle with the calm of proverb appears. Information in a region can be counted at its boundary. The holographic hint ties entropy to area, not volume, an alliance between counting and geometry. If the book is kept on edges, then rates of change and rates of transmission find their ceilings in the fabric's grain. The number we call C looks less like a posted rule and more like the slope of space-time. Another, softer limiter is the sky's slow widening. Dark energy urges expansion to accelerate, laying new carpet between faraway chairs. Many galaxies recede faster than any beam can bridge, not because they sprint through space, but because more space appears between us. Even a perfect photon released today from most of those shores will never arrive. A light-speed ship would still live in a shrinking island of reach. Entanglement tempts with instant intimacy. Measure a particle here, and its partner there falls into a complementary state. Distance be damned. It feels like a wink across the void, but the wink carries no message. Outcomes are random until slow, ordinary communication compares notes. The universe allows patterns that stretch across gulfs while forbidding those patterns from hauling meaning faster than light. Generous with wonder, strict with causation. Practicalities echo the theory. The Higgs field grants mass and makes inertia real. The vacuum's murmur warms under push. The background glow turns dangerous when you all but fly into it. Metamaterials and ultra-cold clouds delay without breaking rules. Odd phases like time crystals hum within the law. Jets fed by titanic engines still stop short. Entanglement refuses to be a telegraph. Expansion writes a horizon that glides away. Every route you try turns its compass to the same north. A human voyage inherits all of it. A ship for decades must be a garden and a workshop, a loop of water and air, harvest in orbit, spares that can be fabricated rather than only stored. Radiators unfurl, shield layers stack, instruments expect false colors, guidance rehearses cones and shifts. The crew calibrates not just fuel and mass, but culture, ritual, rest. A shared calendar that can face a sky where minutes in the cabin can become years on the porch, at home. Hold an image like a slow exhale, a vessel moving through something so clear it looks like nothing at all. Ahead, the stars gather into a bright coin. Behind, night unspools to velvet. Inside, metal smells faintly of paper and tea. The lamps focus into narrow lances. The radiators drink heat into black. Particles tap the hull like dry rain. Fields rise to meet them. The room is respectful of rules that don't bend and don't scold. You can sense the limit without touching it. Neutrinos remind you that proximity is not arrival. Metamaterials remind you that delay is not speed. Condensates remind you that pausing is not cheating. Jets remind you that power is not permission. The microwave sky reminds you that background can become foreground if you rush. Entanglement reminds you that intimacy is not communication. Dark energy reminds you that horizons are not borders you can bargain with. The Higgs reminds you that mass is participation, not burden alone. The pieces fit like tesserae, not as walls repeated, but as stones in an arch. In that arch, light's pace reads as grammar rather than refusal. It keeps causes ahead of effects, navigation meaningful, chemistry faithful, engines honest, and histories legible. It leaves us with plenty to do. Weave clocks that agree across continents, aim detectors that listen for small tremors from far events, shape beams and lenses that touch the faintest signals without breaking the book. The limit furnishes the world more than it forbids it, so the mind can rest here without surrendering curiosity. A confirmed boson, an early rain of neutrinos from a dying star, a slowed pulse in a cold cloud, a glow from the first dawn of time, a jet that blazes but pauses at the bound, a pattern that correlates without carrying the message, a horizon that lifts away while we watch all of them rhyme. They don't slam a door, they tune the room. And in that tuned room, science and sleep feel like the same gentle project, listening carefully to a universe that keeps time, keeps order, and still leaves space for wonder. In that tuned room, there is a hushed reason the cosmos is not instantaneous. If light had no delay at all, forces would crack like whips across space. Electrons could not linger in their soft probability clouds, and atoms would fail to be stable rooms for chemistry. Reactions would flash to completion or never begin. A finite speed of light is the very tempo we've been listening for. the cadence that lets matter keep time, that allows molecules to form, stars to burn slowly, and life to take its patient steps. Shift the lens from molecules to collapsed suns, and the same restraint appears with steel in it. Pulsars, neutron stars, with crusts no taller than hills and densities that shame leads spin like lighthouses. One record holder turns 716 times each second. At its waist, the surface skims along at about a quarter of light's pace. Push harder, and the star would fling itself apart. Even where gravity is billions of times stronger than Earth's, matter won't be rushed beyond certain speeds. Closer to the abyss, geometry takes over the plot. At a black hole's event horizon, space itself streams inward as fast as light can run. To hover would require outpacing that inward river faster than light just to stand still. Theoretical arguments then ask what happens to quantum entanglement at that boundary. If the usual stitching between inside and outside fails, some calculations ignite a firewall, a fierce rind of radiation that keeps information books balanced at a terrible price. Whether the firewall idea survives future work or fades, the lesson is unchanged. You cannot idle at the rim without breaking causality. Another thought reaches back toward the first seconds of everything. Imagine hairline seams in space-time, cosmic strings left behind by phase transitions in the young universe, thinner than an atom, yet heavy enough to tug on galaxies. Could their geometry build shortcuts or closed loops in time? Follow that invitation, and you meet paradox with a patient smile. Messages that prevent their own sending. Travelers who erase their departures. Whenever a configuration tries to ink faster than light paths, the equations defend consistency and close the loop before paradox can bloom. Quantum experiments that seem to tease the past turn out to honor the same boundary. In the delayed choice eraser, you decide whether to keep or erase which path information after a photon has crossed the slits and the data arrange themselves as if the decision reached backward. But no usable signal goes upstream. When you collect all the records at light speed or slower and compare notes, the strangeness resolves into correlations with no way to carry a message into yesterday. Quantum mechanics is odd, and yet the bookkeeping stays honest. Shrink the ruler until numbers tire down to the Planck length, about 10 to the power of -35 meters, and smooth space-time may give way to fizz. In that picture, change cannot propagate faster than a fundamental tick. C becomes less a posted speed and more the universe's refresh rate. It is not a policeman with a whistle. It is the frame rate of reality, the fastest that updates can travel without tearing the film. On a different shelf sits the false vacuum idea. Perhaps our cosmic field is perched in a long-lived, not quite lowest state, like supercooled water, waiting for the first crystal to seed the freeze. If decay began, the frontier of new physics would sweep outward at the speed of light. No warning possible, no siren faster than the change. The same limit that slows our adventures to the stars would also be the ceiling on how quickly everything could end. Influence, danger, and comfort share one stride. Nature performs its own stress tests. Gamma-ray bursts, the brief tantrums of collapsing giants, convert the mass of a star into light and motion with ferocity unmatched since the beginning. Their jets accelerate particles to 99.999% of c, with Lorentz factors that make accelerators look like toys. The beams cross billions of light years and still never pierce the barrier. Even catastrophe signs its work beneath the same constant. If you like cleaner algebra, Special relativity offers rapidity, a measure of motion that adds like angles. You can stack rapidities without limit, translate back into everyday speed, and the result still stays under C. Mathematics and physics conspire like careful friends to keep the ledger consistent, no matter how clever the bookkeeping. Speculative drives try to borrow geometry rather than brute force. A warp bubble would squeeze space in front and stretch it behind so that the ship rides a wave. Locally, it need not move fast at all. The equation that sketches the trick is allowed. The invoice is merciless. You'd need negative energy densities, pressure that pulls instead of pushes on scales not seen in nature. Quantum inequalities growl. Vacuum fluctuations gnaw at the bubble's walls. Radiative instabilities whisper that the structure would tear itself apart before carrying anyone, anywhere. The anthropic whisper threads through all of this. In a universe with instantaneous light, stable atoms disappear, chemistry loses its patience, stars burn out in flashes, and complexity collapses back into simplicity. The value of C reads like a harbor's shape, not designed for us, but hospitable enough that boats can tie up and stories can be told on decks at dusk. Consider how these ideas sound when softened to the scale of a room. You rest while the mind strolls. Somewhere, far away, a pulsar keeps a beat faster than a hummingbird's heart and still refuses to fly apart. Somewhere darker, a horizon hums where space falls inward like a steady waterfall. In another lab, a crystal repeats in time, yet pays every thermodynamic bill. On a chalkboard, rapidity is added like angles. The resulting speed never breaks the ceiling. On another board, a warp throat curves elegantly on paper and stubbornly refuses in practice. Even the small technicalities point the same direction. Information cannot exceed light speed without letting effect pounce on cause. Entanglement can braid outcomes across the universe, but not smuggle a message. Closed, time-like curves promise theater and deliver contradiction. The Planck scale foam may jitter, yet never let an update outrun the tick. Firewalls, if they exist, are the price of keeping accounts straight at a hole's edge. Gamma ray beams strain, roar, then fade under the same ceiling. What remains is not a sense of prison, but of rhythm. Limits feel harsh when written as end quote. No, they soften when heard as time's signature. Within this signature, atoms keep their shapes, molecules practice chemistry, planets carry oceans, and hearts measure out a lifetime without tripping over their own beats. The speed of light is the cosmos saying, go on, but go in order. So you breathe in, count a few quiet numbers, and let the story flow. The universe will not let messages run ahead of themselves, will not let matter sprint until it unravels, will not let geometry fold into paradox. Instead, it gives us paces, a lighthouse star turning, a horizon no one can lean against, a burst that lights half a galaxy and still keeps the rule, a rumor of strings that declines to tangle time, an experiment that tempts the past and then tells the truth when all the records are compared. Physics has a way of closing doors before they are even built. Stephen Hawking gave one such door a gentle name, chronology protection. The idea is not a scold, but a safeguard. The suggestion that whenever geometry tries to fold time into loops large enough to travel, quantum effects pile up like a storm against a cliff. Energies spike, fluctuations roar, and the would-be time route erases itself in its own glare. Since faster-than-light shortcuts would make those loops possible, the same quiet enforcement that protects history from knots also keeps speeds beneath the universal ceiling. Even when matter puts on its strangest costumes, superfluids that slip through pipes without friction, superconductors that carry current without loss, the limit still hums in the background. These are collective states, thousands or trillions of particles moving as one wave, doing things that look like stage magic. Yet signals in those media do not outrun C. A disturbance still takes time to cross a room. Information still moves under the same sky. Quantum weirdness is a new grammar, not a permission slip. Think of the universe as a calculator. No one built, and yet everyone uses. Each interaction is a tick, each change a step. The cosmos computes about its own next frame. Light speed then looks like a clock. Rate the maximum update frequency for reality's great processor. Ask a device to run beyond its clock and the request loses meaning. The instructions have nowhere to land. In this picture, trying to exceed C is not just hard, it is asking a question that has no slot for an answer. Quantum computers add detail without changing the verdict. Their party tricks, superposition and entanglement let them explore many computational paths at once, and for certain problems the payoff is spectacular. But the no-signaling theorem keeps their feet on the ground. Entanglement can correlate distant outcomes, not courier messages between them. Results must still be returned through wires, photons, or radio, all limited by C. Parallelism is allowed. Superluminal mail is not. Clocks near Earth testify to the same restraint with small, stubborn offsets. GPS satellites tick a little oddly from our point of view. Motion tries to slow their time. Altitude in weaker gravity tries to speed it up. The gravitational effect adds about 45 microseconds per day. The orbital speed subtracts about 7. Engineers calibrate the net roughly plus 38 microseconds, so your morning walk doesn't end in the wrong neighborhood. Push the principle toward a black hole and the contrast hardens. Deep in a massive well, time thins. At the horizon, for an outside observer, it seems to stall. Combine this with the slowing from high velocity, and you have a double braid of dilation that no engine can simply cut. Nature throws us fastballs to consider. A single proton once arrived with the kinetic energy of a tossed baseball. A cosmic ray whose speed was so close to C that ordinary percentages do it no justice. The difference from light's pace was a hair's breadth drawn across a galaxy's width there, and yet immeasurably small. If the universe itself can fling a particle with the budget of a star's tantrum and still miss the limit, our machines will not be the ones to break it. Light itself changes character in extreme neighborhoods, and the rule stays firm all the same. Near certain neutron stars, the magnetic field is so intense that the vacuum behaves as a medium polarized, birefringent, rotating the polarization of passing light the way a crystal would. Space seems to acquire a texture, a grain that turns the beam, yet even in that altered passage, signals do not gain a shortcut. The messenger's costume shifts, the itinerary does not. Look outward, and the stage moves under our feet. The discovery that the universe's expansion is accelerating means the map redraws itself while we study it. Beyond a shifting frontier, galaxies recede faster than any beam can bridge, not because they sprint through space, but because more space is being laid between us and them. With each year, more of the great quilt slides beyond our ability to visit or speak to, even in principle. Our observable world, as a place where interaction is possible, narrows in reach even as time broadens our view of what once was. spin a heavy body, and space-time itself is dragged like a slow river around a piling. We have measured the subtle version of this near Earth with gyroscopes in orbit. Around a rotating black hole, the effect swells into an ergosphere, a region where the flow is so insistent that no one can stand still with respect to the distant stars. It is tempting to speak of space moving faster than light, but locally the rule never cracks. Every traveler's watch keeps lawful time. Every nearby ruler measures speeds beneath sea. The swirl is geometry's way of insisting on the same order from a different angle. Another analogy sits in the heart of the strong force. Quarks cannot be coaxed into solitude. Try to separate them, and the connecting field strengthens until the energy you add blossoms into new quark-antiquark pairs. Confinement is not merely a difficulty, it is an absolute. The push to light speed feels similar. The more energy you pour in, the more the structure of the laws pays you back with resistance, radiation, mass energy, curvature, until the route you imagined closes behind you with calm finality. Electromagnetism itself carries the constant in its bones. Maxwell's equations predict ripples that travel at 1 over the square root of epsilon, 0 mu 0, and that number is c. Change it, and you are not merely turning a dial. You are rewriting what electric and magnetic mean. Chemistry would change its handwriting. Spectra would sing new notes. Atoms would adopt unfamiliar personalities. The constant is a linchpin. Pull it, and the wheel is no longer a wheel. Gravity keeps time by the same watch. For decades, a pair of pulsars has spiraled together, shedding energy exactly as gravitational waves would carry it away. The shrinking of their orbit matches the ledger of general relativity with exquisite precision. Later, when two neutron stars collided in a distant galaxy, their light and their space-time ripples reached us almost shoulder to shoulder. After eons, another confirmation that gravity's news travels at sea, never faster, never tardy by more than the processes at the source allow. What emerges is less a single commandment than a chorus. Chronology protection frowns on loops in time. Superfluids and superconductors sparkle and still keep messages subluminal. Computation hints at a cosmic clock rate. Quantum hardware wins speed-ups without mailing answers ahead of schedule. Satellite clocks and black holes demonstrate time's elastic patience. Cosmic rays press close and still fall short. Vacuum birefringence twirls polarization without granting haste. Accelerating expansion writes a horizon that drifts beyond any chase. Frame dragging twists the grid, but not causality. Confinement reminds us that some thresholds are structural. Maxwell pins C into the very weave of light. Binary pulsars and stellar mergers confirm that gravity itself respects the same stride. Seen together, the pieces feel like weather patterns in a single climate. Limits here are not scrawled in red ink. They are the shape of the land. They keep stories readable, machines reliable, measurements comparable, and hopes proportionate. The speed of light is the metronome that prevents the orchestra from dissolving into noise. Under that steady tick, electrons keep their soft orbits. Clocks disagree in calculable ways, and distant explosions write faint lines across our detectors right on cue. The rule is everywhere, and in its way, kindly. Not a slammed door, but a rhythm that lets the world unfold without tripping over its own feet. Proper time is the wristwatch you carry inside your skin. It's the time a thing experiences along its own path, its private heartbeat of before and after. For anything with mass, that inner clock always ticks. For light, it doesn't tick at all. Along a photon's path, the proper time between leaving a star and touching your eye is exactly 0, not slow 0. To reach light speed in a massive body would mean squeezing your own now flat, stepping outside the ability to experience moments. That isn't ordinary time dilation. It's the absence of time, a state clocks, chemistry, and living minds cannot inhabit. On laser tables the size of gymnasiums, we've pushed toward the universe's edges and watched the rules hold. Ultra-intense pulses carve into the quantum vacuum like chisels, strong enough to conjure electron-positron pairs from pure field. The lab becomes a brief storm of matter and light, the vacuum admitting it has a texture, yet nothing born in that storm outruns C. We can bruise nothing, even rip pairs from it. We can't break its speed limit. At the dark edge of gravity, the answer is the same. Hawking radiation seeps from just outside a horizon because tidal gravity pries apart virtual pairs. One falls in, the other escapes with a real, measurable glow. Those particles sprint, but never surpass light. Even where space-time is pulled tightest, the cosmic tempo holds. Physicists keep checking whether the rules tilt with speed, direction, or energy, if Lorentz invariance ever wobbles. Tabletop interferometers, gamma rays from galaxies, polarized light bent around neutron stars. Across all of it, the verdict is steady. The laws look the same to every straight-line traveler, and C is the unchanging glue. There's also the quiet tether between information and heat. Entropy, the measure of spread and irreversibility, walks hand in hand with information. Erase a bit, pay in warmth, specify a state, store the details somewhere real. As a system's speed leans toward light, the number of quantum modes you'd need to track swells like a tide. To describe a traveler pressed to extreme gamma begins to resemble writing down an infinite library. The second law has no room for infinities hiding in finite boxes. A universe that forbids infinite information density also balks at the path that would require it. Engineering whispers the same truth in smaller numbers. The International Space Station glides at to 7.66 kilometers per second, about 0.0025% of C. It took decades, many launches, and constant care to keep that platform alive. To reach even 1% of light speed would demand roughly 400,000 times the orbital kinetic energy budget before counting waste heat, shielding, spares, food, water, and the rituals that keep a crew human. Between what we can do and what a fantasy needs lies not a step but an ocean. And the ocean isn't flat. Dark matter outweighs the familiar atoms 5 to 1, weaving invisible scaffolds through space. A craft rushing at relativistic speed would integrate tiny tugs from filaments and clumps the way a ship feels hidden currents. Navigation becomes a negotiation with a map whose most important lines are drawn in gravity you cannot see, where small errors add up until slight becomes lost. Inside the vessel, plasma turns temperamental. At high gamma, electromagnetic fields compress forward. Collective modes go non-linear. Instabilities that purr in gentle regimes can snarl the two-stream in Weibel instabilities, amplifying tangled fields and kicking particles out of tidy beams. Electronics swimming in that C-face crosstalk and self-field feedback like a system arguing with itself. Any design that relies on charged exhaust, beam writing, or dense onboard plasma has to face its own weather. Even empty space has furniture. Slide two metal plates, a hair's breadth apart, and certain quantum fluctuations can't fit between them. The plates feel a force, the Casimir effect, change motion or geometry, and those fluctuations reorganize. Some calculations suggest a kind of quantum friction that swells as you approach C, a dissipation that punishes the last inch toward the limit. Whether nature pays that exact bill in flight, the message is consistent. The vacuum is not a mere void. It is a medium with rules. Astronomy lets us measure those rules over ages no lab can host. Fast radio bursts, brief, bright syllables from distant galaxies cross billions of light years. Their different colors arrive staggered by plasma fog along the way. But when you correct for the fog, every frequency respects the same. C, radio, optical, X-ray, gamma, same pace, same promise. Now picture a realistic voyage and let the numbers become a feeling. Aim for Andromeda, about 2.5 million light years away, and cruise at 99.99% of light speed. Earth's calendars will stack to 2.5 million years. Your ship's clock, your proper time, might record on the order of tens of thousands of years, roughly 50,000 depending on how you boost and coast. That mismatch isn't a paradox, it's geometry. But the human consequence is stark. Return, and you arrive to 5 million years later, by Earth's reckoning, to languages unspoken, coastlines redrawn, cousins fossilized. The separation isn't only meters, it's years you cannot share. Gravity deepens that tilt. Clocks higher in a gravitational field run faster. Clocks deeper run slower. GPS works because engineers pre-offset satellite clocks, plus 45 microseconds per day for altitude, 7 for orbital speed, leaving a net plus 38 microseconds that would otherwise steer you into the wrong neighborhood. Near a black hole, the slowdown grows so severe that from the outside, time at the edge appears to pause. A real voyage at extreme speed would braid both dilations, velocity and gravity, into a timing problem that refuses to be shrugged off. Nature keeps throwing stress tests. The, oh my God, cosmic ray 1 proton, with the energy of a pitched baseball, arrives so close to C that the difference could hide in the thickness of a hair drawn across a galaxy. Yet even that projectile fell short. Neutron stars polarize the vacuum with magnetic fields that make laboratories feel like toys. Light's polarization rotates as if space were a crystal, and still the messenger's speed does not budge. Binary pulsars lose orbital energy exactly as gravitational waves would carry it away, matching general relativity's ledger year after year. When neutron stars finally collide, the flash and the ripple travel shoulder to shoulder across 100 million years. Set the pieces side by side and a picture emerges. Proper time explains why photons have no during, and why anything that does must never become a photon. Ultra-intense lasers, black hole horizons, and precision Lorentz tests show that even at the edges, ripping pairs from fields, curving space-time into funnels, the limit is kept. Information and entropy sigh at the infinity you'd need to catalog a nearly light-speed traveler. Engineering reminds us how big 1% is when you're already heroic. Dark matter makes routes lumpy. Plasmas add their own weather. The vacuum adds texture. FRBs act as rulers laid across the sky. Andromeda turns kilometers into years and back again. What remains isn't a slammed door. It's a rhythm. The universe advances in frames, not as a blur. Light speed is the tempo that lets causes come before effects. Messages keep their meaning, and memories line up into stories. Under that tempo, there is room to work and to rest. Clocks that argue then agree, detectors that catch fast syllables from far galaxies, lasers that worry at the boundary between nothing and something, models that teach plasma its manners, maps that weigh the dark by its pull. The ceiling is firm, the room beneath it is immense. Let breath settle with that thought. Proper time keeps your minutes honest. The vacuum, prodded and puzzled, stays loyal to its pace. Gravity sings the same meter. Even the universe's most violent outbursts sign their names below the same constant. In that steadiness, science and sleep are cousins. Both are ways of listening quietly, patiently, to a world that keeps order while leaving space for wonder. Bend a beam the wrong way, and it still behaves. In carefully built metamaterials, lattices finer than a hair's width light can be coaxed to turn back on itself, to crawl, even to stall. It's a magician's trick, done with physics instead of smoke. Tune the structure so phase crests slide one way, while the useful signal, the leading edge that carries new information, keeps its dignity. Phase velocity and group velocity may wander. The front, the true messenger, never outruns the universal pace. You can choreograph the dance steps, but you can't make the music arrive early. Inside every proton, another lesson murmurs. Its mass isn't the neat sum of three quarks, the way a coin's value is stamped in metal. Most of that heft comes from motion and Field's virtual gluons exchanged in a constant flurry, a small storm of energy that never sits still. Accelerate the proton, and the storm thickens. The cloud of virtual partners bristles, energy crowds in, and the inertia you push against swells. It feels, from the outside, like mass rising with speed, and it tells you, in its own language, the closer you press toward light's stride, the more the world answers with resistance that is baked into what a particle is. Turn your ear to the sky's most reliable metronomes, millisecond pulsars, and you get a timekeeper's endorsement of the same rule. Astronomers watch those rapid heartbeats for years, listening for any drift in the constants that set the tune of nature. The pulses keep arriving on schedule with astonishing faithfulness. If light speed were to tilt even slightly over vast reaches of time and space, the discrepancy would echo in those rhythms. Instead, the universe behaves like a clock tower that refuses to stutter. Acceleration adds a boundary no road sign could warn you about. Hold a constant push, and an odd horizon forms behind you, the Rindler horizon, a line past which events can never catch up, no matter how loudly they call. Increase the push, and that private horizon creeps nearer. Imagine the impossible demand. Instantaneous jump to light speed, and the horizon would collapse to your shoulder, separating you from everything that once could reach you. The message is quiet but unmistakable. Acceleration writes its own edges into reality, and they tighten as you test the limits. Push hard enough for long enough, and even nothing stops being empty. In the view of quantum fields, sustained acceleration bathes you in Unruh radiation, as if the vacuum had warmed into a low ember just for you. Rack the acceleration higher, and the bath gets hotter. Theory suggests a point where the heat itself would stoke particle-antiparticle creation, each new pair feeding further emission in a runaway glow. The void refuses to stay featureless when you insist on extremes, and those features would not be kind to a ship. Information theory adds a ceiling with a different shape. If the content of any region is bounded by the area of its boundary to the holographic hint, then there is a limit to how densely information can be packed and how swiftly it can be processed. A traveler, driven closer to light's pace, must track more modes, more quantum possibilities, more intertwined details, just to remain described. Somewhere before the last few decimals to see, you collide with a bookkeeping wall. There isn't room, on reality's ledger, to write down what you would need to be while staying finite and lawful. Even where the map looks bare, there is texture. Cosmic voids are not true vacuums. They are quiet rooms full of fields and fleeting pairs. A craft slicing through at relativistic speed would not swim through nothing, but through a medium whose subtleties suddenly matter. Tiny forces that sleep at ordinary pace might nudge your path. Fluctuations that average out for a slow observer might lean in one direction for a fast one. The emptier the region, the more clearly you see the furniture of the vacuum rearrange around your motion. Pull back to the painting's largest strokes, and the humbling fact returns. Light speed is not enough to tour the whole gallery. Expansion accelerates. Far shores recede faster than any beam can bridge because more space opens between us every moment. Our reachable neighborhood is a bubble with a moving rim. Time hands us a longer look at the past as light from deeper distances arrives, yet the list of places we could ever visit, speak to, or influence grows shorter. The speed limit is joined by an architectural choice. Most of the halls are sealed by construction, not by law enforcement. Some theorists take an even more radical angle. Perhaps time isn't a foundation, but a blossom, an emergent flow from the web of quantum correlations. In that picture, what we call before and after arise from how systems become linked, and C is the fastest rate at which such links can build a sensible narrative. Ask for faster than light travel in that world, and you're not just asking to move quickly, you're asking for a story to assemble itself without the threads that make a story possible. The request loses meaning, like asking for a melody to arrive before its notes exist. Meanwhile, the forces we name in textbooks do not ignore your speed. The electromagnetic force, carried by photons, already lives at the limit. The weak force rides massive W and Z bosons that shuffle slower, with ranges so short they barely cross a nucleus. At high gamma, the balance of interactions that keeps matter behaving becomes trickier to describe from the outside. Decay sequences look stretched, reaction windows narrow or widen by relativity's accounting. Laboratory half-lives lose their familiar cadence in your frame, and yet remain perfectly ordinary for those at rest. Chemistry, nuclear alchemy, even the glow of radioactivity continue to work locally, as they always do. But trying to coordinate them across wildly different clocks becomes like choreographing a dance across two stages, with the music sped up on one and slowed on the other. No catastrophe is needed. Misalignment alone makes control feel like handling silk with mittens. Nature constructs its own accelerators and still fails to break the wall. In the narrow throats of astrophysical jets, magnetic field lines snap and reconnect, flinging particles in sudden flares, relativistic reconnection, a cosmic slingshot. The energies are savage. The fields dwarf anything we could build, and the particles depart with Lorentz factors that squeeze the remaining distance to see into a razor-thin margin. The curve rises steeply, approaches the axis, and never touches it. If you take the question inward, to the pace of thought, the limit is there as well. less a handcuff than a measure of how quickly a brain can knit meaning. Neurons trade in electrical and chemical signals that are themselves governed by electromagnetism. Some thinkers speculate that quantum effects may season that signaling in subtle ways. Whether or not the brain leans on quantum spice, the ingredients cannot communicate faster than the messenger that defines communication itself. There's something comforting in that. Awareness grows in a garden, where messages arrive in order, where sensation travels at a knowable clip, where memory is a sequence and not a puddle. Exotic materials have not found a trapdoor either. Topological insulators let electrons slide along their skins with uncanny ease, while the bulk remains stubbornly quiet. The surface states are protected by geometry and symmetry. They shrug off impurities and rough edges. Those protections don't include permission to send a message faster than the limit. Even on their frictionless lanes, signals take time. The cosmos offers long baseline experiments, as generous as they are patient. Light from a quasar may split around a foreground galaxy into several images, each path a different length through curved spacetime. The copies arrive at staggered times, like reflections from mirrors placed at different hallways. Model the lens, measure the delays, check for any whisper of speed that depends on color, distance, or direction. Across billions of years and a wide sweep of photon energies, the pace remains the same. The messenger is punctual in a way that borders on tender. Quantum mechanics returns for a final, polite veto. If you prod a system incessantly with measurements, you can hold it near its starting point. The quantum Zeno effect, the watched pot that refuses to boil. Near light speed, interactions with the sea of virtual quanta become more frequent, as if the vacuum were glancing your way more often. Each glance collapses possibilities back toward what is allowed. You can imagine a barrier that stiffens in the last inches toward the limit, enforced not by walls, but by attention. Step back and the collage resolves. Metamaterials rearrange paths without summoning a courier before the door is open. The gluon storm inside protons explains why shoving harder buys you more reluctance instead of a shortcut. Pulsar timing shows no drift in the rulebook. Acceleration writes horizons that come closer the more you insist. Unruh warmth warns that the void itself grows lively when you push too hard. Holographic bounds whisper that information has a budget, and high-speed plans spend it alarmingly fast. Voids have structure to negotiate. Expansion removes destinations faster than ambition can restore them. If time flows from correlation, asking for more than C is asking the river to arrive before its spring. Forces keep their habits locally and lose their easy coordination globally. Jets snap and flare, yet stay just shy. Brains build awareness on signals that honor the speed of their messenger. Topological lanes glide but do not teleport. Lenses across the universe confirm punctuality over ages. Zeno's paradox gives a quantum shrug as you reach for the last decimal place. Threaded through all of it is a tone not of prohibition, but of coherence. The limit is not a fence scrawled with warnings. It is part of the weave that keeps pages from falling out of the book. Within that weave, there is room for many kinds of travel. Probes that sip ion wind for years. Sails that lean on sunlight or lasers. Trajectories that borrow momentum from planets with the grace of a slingshot. Antennas that listen for brief syllables carried from other galaxies. Clocks that compare notes until they agree on distances we will never walk. The universe hasn't closed its fist. It has kept its narrative readable. Imagine this. Before sleep finishes its slow work, a quiet ferry crossing a dark river. The far bank is real and out of reach. The water moves around the hull in patterns you don't need to compute to trust. Lanterns along the deck make small circles of certainty. Stars overhead are older circles still. The engine doesn't rush. The shoreline doesn't argue. You move through a world that keeps its promises by not granting every wish. And that is why you can rest. Within the pace the cosmos allows, thought can stretch, curiosity can wander, and the night can do what nights do, gently carry you from one page to the next without tearing the spine. Far out in the dark, two neutron stars spiraled together and rang the cosmos like a bell. Their final embrace happened about 130 million light-years away. On Earth, exquisitely quiet instruments LIGO and Virgo felt the tremor, ripples in space-time itself, a gravitational wave. Telescopes caught the light, a heartbeat later. After traveling for more than 100 million years, both messengers arrived within seconds of one another, as if two distant clocks had kept perfect time across a wilderness. Gravity and light, different in nature yet bound by the same pace, saluted the same speed limit with astonishing precision. Some physicists suspect the limit runs deeper than a number you can look up. In certain quantum gravity sketches, space and time might not be fundamental at all. Picture reality not as a smooth sheet, but as a quiet lattice, a network of tiny relations. Loop quantum gravity calls them spins, whose weave gives rise to the space we move through and the time we feel. In a crystal, disturbances cannot outrun the material's own speed of sound. In the quantum fabric, change itself may have a maximum pace, and that pace is what we call the speed of light. Not a rule tacked on afterward, but a property of the loom. Black holes bring the question to a hard edge. At the event horizon, escape speed equals the speed of light. Cross that boundary, and every path points inward. Some theories, trying to rescue quantum information from being shredded, propose a firewall of furious radiation right where that boundary lives. Whether firewalls truly exist or give way to some subtler solution, the motif is the same. The place where light's pace becomes the last possible pace is exactly where the cosmos negotiates how information is kept safe. The speed limit and the bookkeeping of quantum facts are intertwined like two threads in the same cord. Look up at the largest patterns and you'll find the same restraint, written on the sky like careful handwriting. Galaxy clusters gather along long filaments, the cosmic web, because gravity can only tug so fast. If influence could rush infinitely, structure would look different, too crisp or too immediate, like frost forming in a blink. Instead, we see a patient scaffolding, complexity that could only have grown under a finite tempo for gravity's news to spread. The universe's vastness did not become clutter, it became filigree. There is, too, a colder story folded into the rules. If the Higgs field, the invisible field that grants particles their mass, were perched in a false vacuum, not its lowest energy, a bubble of truer vacuum could, in principle, snap into existence. Its edge would race outward at exactly light speed, reorganizing the laws within its growing circle. No warning can arrive faster than that front. No plea can outrun it. The same pace that limits our travels also caps the speed at which everything could, in theory, end. Comforting or eerie, it is at least consistent. Meanwhile, in bright laboratories, people coax the quantum and the familiar to hold hands. Optomechanics lets light reach out and tame motion. Lasers cool tiny mechanical drums until they settle into their quantum ground state. Mirrors the size of rice grains hum with single phonon precision. In these rooms where objects you can see behave like wave functions you can calculate, the old ceiling remains untouched. Whether information rides as a flicker of light or as a whisper in a resonator, its news does not outrun CM. Even where classical intuition gives way and quantum gentleness takes the lead, the messenger is punctual and modest. There's a broader theme hiding in plain sight. Complexity needs time. A living cell is 1,000 conversations at once. A brain is billions. Information must travel among parts, respond, adapt, revise. If you pushed a system toward light speed, time dilation would slow its inner exchange until, in the limit, processes freeze. That stillness is not merely inconvenient. It hints that a world with no upper bound on speed might be too brittle for layered structure to arise. A finite limit gives the universe room to compute itself, room to let stars ignite, chemistry serenade, memories stitch themselves in order, and awareness unfold without tearing. Even in the quantum wilds, you can hear hints of protection, quantum error correction. The art of hiding delicate information in broader patterns has escaped the laboratory and wandered into fundamental theory. Space-time itself may act like a code, distributing information so that local mishaps don't erase the message. If that's true, attempts to cheat the speed limit might be met by the universe's own redundancy, errors detected, violations corrected, the ledger balanced so that causality stays intact, not as a policeman's whistle, but as a self-healing fabric that refuses to let meanings break. The anthropic whisper returns here with a softer tone. We live where the parameters allow living to happen. If light were much faster or slower relative to other constants, electromagnetism could smother or starve the forces inside nuclei. Atoms might not hold their shapes. Stars might never form or burn out in instants. The value of C helps place the world in a narrow valley where complexity can climb neither a miracle nor a coincidence, but a selection effect we cannot escape. We observe a universe amenable to observers. Some philosophers push the thought further. Maybe the speed of light isn't just contingent fact, but a logical necessity of any consistent world with cause, effect, locality, and stable histories. In that view, asking for faster-than-light travel is like asking for a square circle, words that can be typed, concepts that cannot stand together. Geometry, algebra, logic, and physics cohere around certain patterns. Beyond them, not even imagination can propose a test that doesn't dismantle itself. Then there's the playful, unsettling mirror. Suppose the world is computed. If reality is underwritten by a substrate that updates states at a fundamental clock rate, then C is the processor's cycle time translated into physics. Every interaction, every quantum click, every field's evolution would be synchronized to that cadence. Demanding superluminal motion would be like asking software to execute between clock ticks, not merely forbidden, but undefined. Whether or not we live in code, the analogy clarifies the feeling of an absolute pace. All of this lands in the lap of ordinary dreams. A hard limit on speed means we may never visit the nearest stars by stepping across the airlock floor and arriving before the kettle boils. It also means your day makes sense. Cause does not arrive late. Messages do not beat their senders. Stories have beginnings, middles, and ends. Time can be counted on, not because it is sentimental, but because the universe does not permit it to unravel into contradictions. In that way, the light speed ceiling is a kind of kindness, an ordering principle that lets meaning accumulate. Set these pieces side by side and the pattern stands out. Gravitational waves and light, born in a single cosmic event, keep the same appointment after 100 million years. Quantum gravity pictures sketch space and time as emergent threads, the limit rising from the fabric itself. Event horizons mark the place where that limit becomes geometry's last word, perhaps even a firewall's home. The cosmic web's lacework testifies to a finite tempo for gravity's pull. Vacuum decay, a theoretical thunderclap, would travel no faster than c. Optomechanical gadgets, half mirror, half melody, behave oddly and still respect the ceiling. Complexity requires time to move within itself. Freeze that internal dialogue, and the song stops. Error correction may be woven into existence, catching and mending would-be violations. The value of C sits in a narrow, life-friendly slot, neither swamp nor desert. Logic itself seems to side with the limit. A simulated world would read it as clock speed, and our hopes, tethered to causal order, find meaning because the world moves no faster than its own heartbeat. If you need a picture to sleep by, try this. Not a wall, but a horizon with a steady glow. On one side, the night sky. On the other, the faint outline of fields, too subtle to name. Signals move like lanterns carried along a shoreline, visible, dependable, never leaping ahead to startle the next watcher. Galaxies arrange themselves as if following a slow dance the whole hall can hear. Deep in that hush, black holes hide their secrets without cheating, and the vacuum, when asked impolite questions, clears its throat and answers only what it must. The limit is everywhere, stitched into mechanism and meaning alike. Under that stitched sky, thoughts can dawdle, dreams can form, and the heart can follow a tempo that neither rushes ahead nor lags behind. Gravitational waves gave us a new kind of listening. They are ripples in space-time launched by collisions so fierce that light alone cannot tell the whole story. Black holes folding into one, neutron stars unwinding and mixing the periodic table. Those ripples took more than 100 million years to reach us, and yet their arrival matched the light within heartbeats. Different messengers, same schedule. The universe speaks in several voices, but it keeps one tempo. Even when the message is carried by space-time itself, it travels no faster than the constant that knits cause to effect. Much of our dreaming points toward shortcuts, a bubble that nudges space to move for us, a tunnel that connects distant rooms, a pairing of particles that seems to whisper across a gulf. The mathematics can sketch these ideas with elegance, but the invoices are relentless negative energy no laboratory can muster, conditions that collapse into paradox, corridors that evaporate when quantum details are added. The lesson is not meanness, it is coherence. The speed limit is not an engineering puzzle to crack so much as a property of the stage on which engineering is possible at all. There is a private ache in that. Most of what we can see will slide out of reach, carried beyond the horizon by the universe's accelerating stretch. Imagine a night when the sky of the far future holds only the stars of our local neighborhood, the rest erased by distance and time, and yet our moment is generous. We live while the archive is open. We can read toddler galaxies in their first light, watch clusters form, measure echoes from the universe's hot beginning. Finite speed is the reason the sky is a history book. Without delay, there would be no deep past to study, only a flat, relentless now. If minds like ours exist elsewhere, they keep time by the same rules. There are likely no empires coordinating across thousands of light years with instant replies. There are likely only islands, each writing its own chapter, launching bottles into a sea that takes centuries or millennia to carry them ashore. The speed limit does not isolate you uniquely. It is evenly fair. In the quiet of night, that symmetry can feel less like loneliness and more like kinship, a recognition that every watcher under any sun must learn patience. The limit is not a locked door. It is also how connection works. Fields are the threads by which particles know one another, and those threads tighten outward at the pace of light. A change here becomes a widening sphere of updates everywhere. That orderly spread builds the web of influences that lets structure grow. Stars accumulate, planets cool, molecules try combinations, cells coordinate, thoughts become patterns in tissue. Communication with a finite stride is not a flaw. It is how separate things can cooperate without collapsing into chaos. Technology will keep leaning on the boundary, and it should. Each attempt is an instrument held closer to the grain of reality. Accelerators teach us what matter becomes when pushed, where symmetry hides, and how it breaks. Faster craft will stitch the solar system into neighborhoods of practice mines, greenhouses, observatories tucked into shadows and perched over bright horizons. None of that breaks the limit, and none of it is small. A boundary can make a project larger by giving it shape. Humility grows naturally here. We are brief and local, and still we have learned to measure tremors, from distant collisions, to weigh invisible matter by its pull, to time starquakes, to microseconds, to cool small mirrors to their last quantum whisper. Wonder grows beside humility, not opposite it. The more the limit proves itself, from detectors humming in vacuum to telescopes gathering old light, the more elegant the world feels. Consistent enough to trust, strange enough to love. If the limit frustrates our travel, it also shelters our meaning. Causality stays upright, stories unfold forward, decisions sit in front of their consequences. Without that order, memories would smear. The difference between prediction and recollection would blur, and experience would refuse to cohere. The speed of light is the measure that keeps time from fraying. It is the quiet work behind clocks agreeing, behind chemistry being reliable, behind planets tracing curves that can be plotted and trusted. There is a gentler gratitude to be had. The sky's delay gives us time maps. The moon is always a second younger. The sun is 8 minutes ago. The nearest stars are a few years in the past. Distant galaxies are fossils glowing. Astronomy is the only science that can look backward directly. The finite speed of light turned the night into a museum with living exhibits, and you are walking through it every time you look up. So what to do within a limit that won't budge? Build precise ears and long eyes. Write instruments that hear tremors from collisions you'll never see. Craft probes that can coast for decades and still phone home. Trade quick conquest for patient cartography. Treat every dataset as a shoreline you can walk. Every measurement as a stepping stone across a river that is too wide to leap. Curiosity is a kind of travel, and the map it draws can reach where feet and hulls cannot. If these quiet explorations help you rest, a light touch on like and subscribe quietly widens the circle. No rush, no pressure. It helps this little harbor stay lit for others who also fall asleep better with a cosmos in their thoughts. Before the lights dim, keep one last image, not a wall, but a path that asks for steady shoes. Gravitational waves and starlight move along it together, on time, after ages. Ideas about bubbles and tunnels test the edges and come home wiser. The sky's deep past remains readable because messages do not sprint. Possible neighbors wait on their own shores, watching, sending, hoping, and you, here, breathing slower now, can lie under a ceiling stitched with distances and still feel connected to everything it contains. Look up when you can. The stars will not meet you halfway, but they will keep their appointments. Their light is a faithful courier traveling at the only speed the universe allows, carrying news from far cities you may never visit and stories from times no one remembers. That is not a denial. It is a gift. Evidence that reality chooses order over confusion, and that within that order, minds like ours can notice patterns, ask honest questions, and be soothed by answers that fit. If you're drifting, let it happen. Let the numbers turn soft at the edges. Let the constellations become the gentle hum of a far highway. The limit still holds, and because it holds, the world is readable. We are made of star stuff, paced by light, small enough to be tender with one another, clever enough to hear the rumble of distant mergers, lucky enough to be awake in an era when the archive is open. Sleep well under that constancy. The universe will keep time. As it keeps time, we've traced the coastline of one quiet idea. Nothing outruns light. We leaned on Einstein's geometry and proper time, watched clocks and satellites disagree, and then agree, felt the rocket equation's steep cliff, listened to LIGO's chime arrive with starlight, and followed limits written into Higgs fields, quantum foam, error-correcting patterns, and the lacework of the cosmic web. We saw shortcuts fade, warp bubbles, tunnels, spooky correlations, and learned that the same constant that slows our travel also preserves causality, writes history into the night, and leaves enough room for complexity, memory, and mind. This isn't a wall so much as grammar, a tempo that lets the universe make sense. Hold that cadence the way you hold a breath. The stars are far, yet their stories reach you honestly, on schedule. Let that steadiness settle in your chest. Close your eyes. The cosmos will keep the beat until morning.